today we're going to be talking about set builder notation. So previously we talked about sets and how we define them, but today we're going to look at a more powerful way to define sets. So I'm going to start writing a set, right, in this notation, and then I'm going to explain what this actually means. So this is a set called A, and this set is X such that 1 is smaller than or equal to X, but X is smaller than or equal to 5. So what this means is that all numbers between 1 to 5 is now part of this set A. So if I were to try and write this manually, 1, and then I'll do 1.1, but I've missed some, so as we go 1.01, but that's still not small enough. And on the other end of the spectrum, I can have 5 and 4.999, etc. Right? Everything imaginable in between those two numbers. That's a terrible break. That's all that this top line is saying. Now we can get even more precise and say, what if I only want even numbers in my set? So let's redefine it. If we want all even numbers between from one number to the next, well, first we write 2x, so times x, and then we define it as part of the natural numbers, and then we'll say such that, and then we will continue with our constraints. So 1 smaller than or equal to x and equal to 50. So what that does is that'll give me all even numbers between 1 and 100. So what it's doing is that it's saying that 2x, whatever that is a natural number, so numbers like 1, 2, 3, etc. But the rule is that x has to be between 1 and 50, right? So that means that is 2 times 1 plus, then next bit of the set 2 times 2, and then the next bit 2 times 3, and so on, all the way to 2 times 50, right? And that's our set. That's what we've written, right? That's the exact same as what we've done with A, right? But you can see that this is just 2, this is 4, this is 6, and this is 100. So all we've done is we're getting all even numbers between 1 and 100, right? You can see how powerful this can be just by changing some parameters around. What if we want all multiples of 5 between 1 and 100? Change this 2 to a 5, and change this 50 to 20. And now we have this as our set. So we have A is equal to 5 lots of 1, and then 5 lots of 2, and 5 lots of 3, all the way to 5 lots of 20. So now we just have 5, 10, 15, 100. We're doing the same thing, we're just changing the multiple, right? Another thing that we can do is changing this to negative numbers, so negative 20 is element of integers this time, right? So this will give us 5 lots of negative 20, 5 lots of negative 19, etc. All the way to 5 lots of nothing, and then 5 lots of 1, etc. All the way to 5 lots of 20 again, right? And you can see how powerful this can get really quickly, because if we want a set that's got all numbers between 1 and 1,000, right? Equal to 1x. Right, this contains all numbers, like this contains pi, this contains root 2, this contains things like 4/3, the list goes on, right? Every number that you can think of that's in between this, between 1 and 1,000, it's all here in this set. And don't ask me why you would want this set, but regardless, it's here, you can define it. So this is really good to follow on to interval notation. So interval notation is where instead of writing that huge line, we can just write this. So now it's saying the exact same thing, right? Let me say that it's saying the exact same thing. It's 1 to 1,000, and we're saying that so if we imagine this on a number line, right? We're including 1, so we'll put a solid line. Here's 1, and here's 1,000, and we have another solid dot there, and then we draw a line. That's a terrible line. I'm gonna do that. If we drew a line from here to here, and that's our number line. That's what it's including. Everything in there. Everything in this space here. All of it. All of it in here. Alright, let's think. What if we want to say all numbers just greater than 1? So then we can write infinity. And then we use a different bracket, right? Because infinity isn't a number, so we can't include infinity. So we change our number line to suit. We have infinity sign, but we have a hollow circle at the end instead of a solid one. If we want all numbers, if we had something like this, that means that we're not including 1, but the number right after it, infinitely small, and that's included. So you can see how we can make what we wrote beforehand a whole lot easier and simpler, and we can always use infinity here, like negative infinity. So now I'm saying that all numbers existing are on this line somewhere. So that's it for this video on set notation and interval notation as part of the number systems topic. If you have any questions, feel free to leave a comment or uh, contact me on social media, and I will see you in the next video.